What's going on YouTube? It's the Middle School Math Man. This video is going to be on proportions and cross products. So we have a little bit of information up top for you on proportions. It talks about these cross products and how they are equal. If you wanted to define what a proportion is just equal fractions or equal ratios. So where it says, where does this come from, I want you to write down a new problem. I want you to write down 6 over 12 equals 3 over 6. So what we're going to do what we did up top, or not what we did up top, but what the example is showing us up top. We're going to take this idea of cross products, we're going to cross multiply. You might have seen these butterfly wings before, just showing us we need to cross multiply. So let's see what we get when we do that. So the butterfly wings tell us 6 times 6 and 12 times 3. So 6 times 6 is equal to 36. 12 times 3 is also equal to 36. So I would ask you, is this a proportion? And you would say, yes, it is a proportion, because when you cross multiply, those cross products are equal. So those fractions, those ratios are equal. There's another example below with a little bit of information about how to identify proportions. Basically just talking about what we just did. So we have an example, 6 over 9, 8 over 12. So let's see if these ratios are proportional. And again, how we do that is we take their cross products. So if you want to draw in your little butterfly wings, so that tells us 6 times 8 not 6 times 8, 6 times 12 and 9 times 8. Now both of those are going to equal 72. So yes, those fractions are proportions. They are equal fractions, and we know that because we took the cross products. Here are some examples with variables. So another question I could ask you is, use cross products to solve proportions with missing values. So again, we are still going to cross multiply. So in this first example, when we do that, we are going to get 10 times x. 10 times x is just 10x equals 36. So now we have a little one-step equation. So just a reminder, if we are solving for x, we need to divide both sides by 10 because that is 10 times x. So we're going to get x equals 3.6. If you plugged in 3.6 into our original problem for x and cross multiplied, they would both equal the same thing. Doing it again on the other example, d times 2 is just 2d equals 7 times 3 is 21. So we are going to get d equals 10.5. So not too bad. That's another type of question I could ask you. Now over here, I'm actually going to cross out the answer, and we're going to solve it together. So the problem reads, a microscope slide shows 37 red blood cells out of 60 blood cells. How many red blood cells would be expected in a sample of the same blood that has 925 blood cells? So we are comparing red blood cells to total blood cells. So very important when you're doing word problems is to be consistent when you're setting it up. So here, we're taking the red blood cells to the total blood cells. So when you get down to solving the actual proportion right here, on both the top and the bottom, the numerator and the denominator, you have to be consistent. So we're going to have 37, because that was from the first part of the problem. We had 37 red blood cells and 60 total blood cells. So we had red over total. So now when we're setting up the other side, we need to have red on the top and total on the bottom. Otherwise, we're not going to get the correct answer. We have to be consistent. So the second part of the problem reads, how many red blood cells? So right there it tells you we don't know the amount of red blood cells, so we have an X to represent that in a sample of the same blood that has 925 total blood cells. So my proportion is going to be right here, 37 out of 60, and then in that same sample we're trying to figure out how many red out of 925. So we have a proportion here. Just like we've been doing, we're going to cross multiply. So 60x equals 925 times 37 is 3,425. And then divide both sides by 60 to get x by itself. And we're going to get x equals 570.42. And again, that means, looking at that sample or that microscope slide, if you multiply that, so now there's 925 total blood cells, you would expect there to be about 570 red blood cells taking that same sample. So this is just a summary. Proportion is an equation stating that two ratios are equal. We talked about that. Cross products is when you cross multiply, and we use those to determine if it forms a proportion. Again, when you cross multiply, if they both equal the same thing, then you know it's a proportion. And we also solve for missing values. On the back of your notes, there's a little bit more practice. So, I think that you can handle A through C for both types. The top part is just, using your butterfly wings, cross multiplying to see if they are equal. So let's just do A together, actually. So we're going to have 3 times 8 and 2 times 12. So both of those equal 24. So yes, that ratio forms a proportion because they are the same. If they are different, they are not going to form a proportion. Again, down below, using the cross products to solve proportions with missing values. Just going to cross multiply and solve for that variable. I do want to do a word problem with you. So, let's look at the Molly example. Molly bought 2 heads of cabbage for $1.80. How many heads of cabbage can Willie buy if he has $28.80? So, the first thing I'm going to do is I'm going to write down what's going to be in the numerator, what's going to be in the denominator. So I'm going to put cost over heads of cabbage. So, Molly bought $1.80 and she got 2 heads of cabbage. So Willie has $28.80, and we want to know how many heads of cabbage will that get him. So I got cost over cabbage, and I was consistent through both sides of that proportion. So when I multiply, I'm going to get 1.80x equals 28.80 times 2 is $57.60. So when you divide, it looks like with $28.80, 57.60 divided by 1.8. If you have $28.80, you should get about 32 heads of cabbage. And that answer should make sense. Molly bought 2 heads of cabbage for $1.80, so she can buy a little bit more than a head of cabbage, $1. So $28.80 is a little bit more than a head of cabbage per dollar. It's going to be 32 heads of cabbage.